Alright, the area inside the blue curve, outside the green. Alright, so this gray shaded region is inside the blue rose petals, but outside the green circle. However, to find the area of the sum of all those gray regions, let's just find a part and then multiply. Which part should we do? Let's just find this one part in quadrant 1, and then we'll multiply it by 1, 2, 3, 4, 5, 6, 7, 8. We're going to sweep this windshield wiper starting from here. We're going to sweep it this way, stopping when it sweeps to this point. So when we're pointing in this direction, theta will be 0, and theta will grow until we get to this point, which is the theta value where the green curve and the blue curve are equal to each other. So then, when are they equal to each other? Let's find theta where these graphs intersect. Blue curve is equal to the green curve. Cosine of 2 theta is 2 fourths. So at this stage, think of the unit circle. We have ourselves a cosine ratio, which is a half. So that's the x-coordinate. The x-coordinate is also half over here. So which angle has a cosine ratio of 1/2? Well, that would be pi over 3 and negative pi over 3. And who is the angle? 2 theta. Therefore, theta is positive or negative pi over 6. Now, for this angle, we could also add another 2 pi and be coterminal. Or we could subtract 7 rotations, so 7 times 2 pi. Or we could do this angle and add another 2 pi or 4 pi or 6 pi or 8 pi, or subtract any multiple of 2 pi. So we could say that the angle in this yellow box that gave us a cosine ratio of 1/2, the angle that's in that box can be positive or negative pi over 3 plus any multiple of a full rotation. And therefore, if we multiply both sides by a half, it's positive or negative pi over 6 plus n times 2 pi times a half, or just n pi, where n can be any integer, which means positive or negative whole numbers. All right, so since we're just sticking to this one region, it's probably going to be when theta is just pi over 6 and 0. So from 0 to pi over 6. I shouldn't say probably, it is going to be when theta just goes from 0, which represents this angle, to pi over 6, and that will be where we stop. So here comes the final answer. The area of all those gray regions will be 8 of these yellow things. So 8 of those yellow things, which go from 0 to pi over 6, 1/2 times the blue radius squared minus the green radius squared, d theta. And this is a calculator problem, so you can enter that into your calculator, and we should get the area is approximately 15.306 square units. Alright, that's how you do this problem using a calculator. I noticed the answer key gives this answer as though they didn't use a calculator, 4 root 3 plus 8 pi over 3. If that's why people check the box, know that we aren't going to be doing difficult definite integrals without calculators until we've reviewed that. So the first semester, we could put this problem into our calculator. If you tried this without a calculator, that's good practice for next semester. I'll go over that in, right after this and the next slide, but you can ignore it. And there you have it. Again, this would be a calculator problem this semester, but I'll expect you to be able to do this integration without a calculator next semester.